Hello everyone, and welcome. Today, we are going to unlock a powerful technique used by chemists, IR spectroscopy. We'll learn exactly how to use an IR spectrum to act like a detective and tell different chemical compounds apart. It's all about identifying molecular fingerprints. Essentially, IR spectroscopy works by shining infrared light on a sample. The bonds within the molecules absorb this energy and start to vibrate. A graph, called a spectrum, is produced, showing us which frequencies of light were absorbed. The key to distinguishing between compounds is to look for the presence or absence of specific absorption peaks, which correspond to different functional groups. Let's look at the most important ones. First, the superstar of the IR spectrum is the carbonyl group, the C double bond O. This appears as a very strong, sharp, and unmissable peak right around 1700 wave numbers. If you are comparing a compound with a carbonyl, like a ketone, to one without, like an alcohol, this peak is your definitive clue. The ketone will have that huge peak at 1700, while the alcohol will not. Second, let's talk about the hydroxyl group, the OH bond. This peak is the complete opposite of the carbonyl peak. It is very broad and rounded, often looking like a big, wide U-shape. In an alcohol, this broad peak appears around 3200 to 3600 wave numbers. If you need to distinguish an alcohol from an ether, which both contain oxygen, you look for this broad OH signal. The alcohol will have it, but the ether will be completely flat in that region. A carboxylic acid is special because it has both a carbonyl group and a hydroxyl group. So, it will show the sharp C equals O peak around 1700 and an extremely broad OH peak that can stretch all the way from 2500 to 3300. Third, we can even get clues from CH bonds. Look at the region around 3000 wave numbers. Peaks that appear just to the left of 3000 indicate CH bonds on double bonds or aromatic rings. Peaks just to the right of 3000 are from CH bonds on saturated, single-bonded carbons. So, the strategy is simple: draw a mental line at 1500 and focus on the area to the left. Look for a big broad OH peak, then look for a strong sharp C equals O peak. By systematically looking for what is there and what is missing, you can confidently identify the functional groups and distinguish between different compounds. Thank you so much for watching. If this guide helped you understand IR spectroscopy a little better, please show your support for the channel by liking this video, subscribing, and sharing it with anyone else who might find it useful. Your support is greatly appreciated and helps me continue making these tutorials. See you next time.